Everyone. Today we are looking at graphs of trig functions. This is the last lesson we have left in chapter 10. And this will kind of link together trigonometry with all of the other algebra concepts we've really talked about this year. Okay? So I'm actually only going to do part of this lesson with you. I'm going to do the sine function graph, and we're going to talk about some of the properties and some of the aspects of it and things like that. And then you're going to do an activity where you actually work through the cosine function on your own, okay? So a couple of things I want you to do before we get started here. We are going to start by graphing the function y equals sine of x. So x is like our angle measure, and you can see that our x-axis I have labeled in radians here. However, I didn't realize when I drew this up that in Algebra 1, we focus much more on degrees in terms of the graphs. In Algebra 2, you're going to see it in radians all the time. But would you just take a second and change these? So for example, pi is actually 180 degrees. Okay. 2 pi is 360 degrees. Let's see, 3 pi is 540. I don't know if we need to go much further beyond that. 4 pi would be 720. Okay, and then like negative pi would be negative 180. So same thing, just numbering in degrees instead of radians. Okay, and then the other thing I'd like to do before we get started here is up in the corner of your paper, we're going to sketch a unit circle. But we actually only care really right now about kind of the four corners, these right here. And I'll show you why in just a second. So I'm going to assume that you know what angle measures all of those are. We're just going to put the coordinates on here. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so now what I want to do is graph where the x value is my angle measure and the y value is my sine. Okay, and remember that sine is the second coordinate. Sine is the y value. So when I'm looking at sine values, I'm looking at the y coordinates all the way around, okay? And let's get an idea of what this is going to look like. So at 0 degrees would be right here, my sine value is 0. So I'm going to put a dot at 0. And I'm actually going to cut these in half here. So this would be 90 here. This would be 270. You don't have to label all of them, but I'm going to go to 90 degrees. And at 90 degrees, my sine value is 1. So I'm going to put a dot up here at 1 for 90. At 180, I'm back to 0. Down at 270, my sine value is negative 1. So that's going to be way down here. And at 360, I'm back to 0 again. Okay? And so if we were to keep going from 360, if we were to go another 90 degrees, that would take us to here, and we'd be back at 1 again. And then if we were to go another 90 to 540, which would be here, we'd be back at 0. And so on. I hope that you can see the pattern here, that this is going to just, whoops, I put that dot too high. Ignore that. This is just going to continue. Okay, it's going to go over and over and over again. If we went backwards around the circle, if we went backwards negative 90, which would be here, our value is negative 1. If we went back negative 180, our sine value would be 0. And so this pattern continues, and what this is really going to look like on our graph is something like this. This should be sort of a smooth curve up and down, not like sharp and pointy. Okay? Although when you put the dots on here like this, it's hard to make it not look pointy. But this is what the sine function looks like, okay? And so what this is doing is this is just going around and doing sine here, sine here, sine here, sine here. And really all those angles in between would exist too. Let me just show you something real quick here. So this right here would be 45 degrees, right? And so we see this value here, and we can't really tell what that is, but we know from our circle that the sine of 45 should be square root of 2 over 2. So if we look at the decimal equivalent of square root of 2 over 2, it's 0.707. And so if you look at 45 degrees, this value right here should be 0.707. Okay? So all of your other angles are represented here too, but all of the other ones are just kind of ugly and weird. So that's why you can see we usually just use these four to kind of establish our graph, okay? Okay, so let's talk about some things. First of all, I hope you get that this is going to continue forever and ever, and it kind of goes in these cycles, right? And so the fact that it cycles makes this a periodic function. Periodic just means it repeats over and over and over again, okay? And we're going to talk about that when we talk about the period of the function. But just to establish that it repeats forever and ever, your domain is what x values are possible here. Well, anything, right? This is going to go on forever to the left. It's going to go on forever to the right. And so our domain here is all real numbers. We can take the sine of anything. We could put anything we want in there for x, okay? For my range, my y values, the highest they're ever going to be is 1, and the lowest they're ever going to be is -1. Do you see how it cycles back and forth between 1 and -1? So we want to say our range is between -1 and +1. That's how we would write that. That our y values go up and down between -1 and +1. Okay, x-intercepts are a little harder on this one because it goes on forever, right? So we can see that it crosses x at, here, it crosses x at 0, and it crosses x at 180, and it crosses x at 360, and 540, and 270, and so on. Or sorry, not 270, 720, and forever and ever and ever, right? So there's a couple different ways we could say what the x-intercepts are supposed to be. I think the easiest way for this one would be multiples of 180, right? So every 180 degrees, I'm crossing the x-axis, okay? We can also say we're starting at 0 and then adding 180 degrees n times, okay? So I can add 180 degrees once. I can add 180 degrees twice. I can add 180 degrees 3 times. And so that's what this notation is really saying, is that we're starting at 0 and adding 180 over and over and over again. Now, what you might see is you might see people just writing that as 180n, and that's okay too, okay? So however you're writing it, you just want something that says every 180 degrees you're going to have an x-intercept, okay? The y-intercept, though, there's only one of those because the y-axis is over here, right? And there's only one place that we cross the y-axis, and that, for this particular graph, is right at 0. Okay, so the y-intercept here is at 0. Now, the period is talking about how far do we have to go before the cycle kind of starts to repeat. And if you look at where we started at 0, and this goes up and down, and when it hits 360, that's when I'm back in the starting position, right? So what I just traced here in blue is one full cycle. And that's 360 degrees from here to here, okay? And so really, your period here is 360 degrees, which I hope makes sense if you think about the circle, that going around one full time is where you start repeating, right? You go around one full time, and then you repeat, and you do it again, and then you repeat, and you do it again. So one full cycle is 360 degrees, and that's what we mean when we say the period is 360. Okay. By the way, that also means, like, if I were to measure from the top of this bump over to the top of this bump, that would also be a distance of 360 degrees. Or from the bottom of this bump to the bottom of this bump. Anywhere where it repeats is going to be a distance of 360. Okay? Okay, so that's really it for the sine function. And remember, when we did sine, we looked at the y-coordinate because that's where sine is on our graph. In just a minute, I'm going to ask you to do the bottom part where you do the cosine function. And it's going to be very similar with some differences. So you are going to take a minute, and you can do it right on your notes packet. Just follow the same procedure we just did. But then there's going to be a question that asks you to actually submit that. And you can take a picture of it right from your notes and submit it that way. Okay? And then after you finish that and answer the questions about it that are posted there in GoFormative for you, you're done with the lesson for today, and you can get started on homework. Okay? All right, thanks. Have a great night.